Hi, it's Miss Bland, and today is Tuesday, August 25th, 2020, and today we're talking about classifying matter. This is the first part of a two-part lesson that we will complete tomorrow. For your do now, I want you to describe as many traits or characteristics as you can think of this matter shown. If you don't know where to start, you can think about these questions. What does it look like? What does it smell like? What happens to it if it gets wet? What happens to it if it gets hot? What happens if it goes to a landfill? What is it made out of? Pause the video and write down as many characteristics of this matter that you can think of. Here are a few examples of properties of this matter. They are soft. They're made of sugar. They have a smooth texture. They are squishy. They dissolve in water. They can burn. They're edible, and they have a cylinder shape. We'll talk more about these in a moment, but these are just some ideas, some examples of things that you can write down. So we have two objectives today. The first objective is that Knights will be able to classify matter as either substances or mixtures. The second objective is that Knights will be able to create models to represent either substances or mixtures. And the models that you'll be creating are just drawings or diagrams. So let's talk a little bit about properties of matter. Yesterday, we saw that all matter has specific properties, and those properties are completely dependent upon the atoms that make it up. That's what I mean by chemical makeup here. The two examples that we looked at yesterday were phosphorus and sulfur. Some properties of phosphorus are that it's reddish-brown, it's a solid at room temperature. Some properties of sulfur is that it has a very strong odor and it's bright yellow. These properties are completely dependent upon the atoms that make it up. Now, these two examples are pure, meaning these are elements that are on the periodic table, but each of those elements can combine with other elements to make different types of matter. And so the way that they combine with each other also impacts the properties that they have. We're going to talk about two different types of properties of matter. So properties can be either physical properties or chemical properties. A physical property of matter is a characteristic of matter that can be observed without changing the identity of the sample. And when I'm talking about the identity, I mean the atoms and molecules that make it up. If I can look at matter and tell a certain property about it without changing it, that's a physical property of matter. Some examples are texture, color, odor, density, solubility, which is its ability to dissolve, conductivity, which is its ability to carry electricity, and its melting point, so at what temperature it melts, or its boiling point, which is at what temperature it boils. Those are just a few examples. So some physical properties of this firewood is that it's solid. It's brown. It has a specific density that we could calculate, and the density depends on what type of wood it is. Those are just a few. Now, a chemical property of matter is a characteristic of matter that can be observed only by fundamentally changing the identity of the sample. That means I have to change the atoms and the molecules that make up the object to tell if it has that property. There aren't as many examples of these, but a few of them are reactivity, so will it react with another substance? Flammability, will it catch on fire at a high enough temperature? Or toxicity, is it toxic to humans or animals? A chemical property of this firewood is that it's flammable. Once I burn it, it's not wood anymore. Its identity is completely different. The molecules that make it up have changed, and so being flammable is a chemical property. So let's look again at the properties of marshmallows that we wrote down last time. I'm just going to paste the ones from before. And if we think about chemical versus physical, Which of these properties are physical? Which of these properties are chemical? Pause the video and see if you can figure it out. As you can see, we have a lot more physical properties than chemical here. The only two chemical properties we have are that they burn under extreme temperatures, and after they burn, their molecules are different, so that's how we know it's chemical, and they're edible. To know if they're edible, we have to actually eat them, and as you know, after you eat something, it is not the same anymore. The rest of these are physical properties. I can tell that it's squishy just by squishing it. After I squish it, it's still a marshmallow. Its identity is still the same, so I know it's a physical property of matter. Now we can use those physical and chemical properties to classify matter. Now what does it mean to classify? When we classify something, we arrange things in classes or categories based on things that they have in common. So why do you think we, as scientists, would want to or need to classify matter? I want you to pause this video and think about that question. In science, we classify pretty much everything. We classify matter just as much as we classify living things, right? We have animals and plants, and then we have bacteria, we have protists, and in one of those categories, we have even more categories. Like in plants, we have trees and shrubs and grasses. Classifying things is helpful for us to understand how they work, understand how they interact with each other, and understand their similarities. So we classify pretty much all matter into two primary groups. But before I tell you what those groups are and their definitions, I want you to try just based on observations. Now, an observation is anything that you can sense about something. In this case, since you're just looking at some pictures, your observations will just be things that you can see. On the next slide, I'll show you some examples, and I want you to try and put these into two groups based on what they have in common. So your hint is it has nothing to do with colors. It's all about structure. And your other hint is that there are 4 in each group. Here are your examples. Try and create 2 groups of 4 based on things that they have in common. Okay, so let's look at these 2 groups. The 2 types of matter are substances and mixtures. So let's start with substances. A substance is any sample of matter with a uniform composition and uniform properties. Now, when I say uniform, I mean that every individual particle is the same. In this image, you'll see that every individual particle has 1 green atom and 2 small yellow atoms. Every single one is the same. Number 3 has the same thing in common. Every single particle is made out of the exact same atoms, which are 2 yellow ones. Number 5, every single particle is exactly the same. Number 7, every single particle is exactly the same. These are all examples of substances because each example, these are all examples of substances because in each example, every single particle is exactly the same. Here are some real-life examples of substances. Water is a substance because when you're looking at pure water, every individual molecule is H2O. Pure gold is a substance as well. Every atom is just gold. Iron is another example because every atom is an iron atom. And table salt is another example. Every particle is 1 sodium atom bonded to a chlorine atom, but every particle looks exactly the same. The other type is mixtures. So a mixture is any sample of matter that's composed of 2 or more substances that are combined, but each one has its properties still. It stays the same. They don't actually bond together. Number 1 is an example of a mixture because this is a combination of two different types of particles. Same thing with number 4. We have a combination of two different types of particles. Same with number 6. Same with number 8. Each of these particles is different, and that makes it a mixture. Some real-life examples of mixtures are salt water. Salt water is water and salt mixed together. The water keeps its properties and the salt keeps its properties, and so it's a mixture. Brass, which is a metal alloy, is a mixture because it is made out of a combination of copper and zinc, two elements on the periodic table. Chex Mix is a mixture. You have all these different things that are combined, but each thing keeps its own flavor, its own texture. Same thing with tea. Tea is a combination of the materials in the plant and water.